Hey everyone! Welcome to a lesson in Section 3.7, which covers the definition of perpendicular lines. The concept of perpendicular lines is very important in engineering and planning a construction site, so we'll be covering the basics in this section. Let's start off by looking at the definition of perpendicular lines. Here, it states that perpendicular lines are lines that intersect to form a right angle. Our diagram here illustrates line M perpendicular to line N. These are the symbols that we're going to use, and again, this is read as line M is perpendicular to line N. And recall that we use this little square symbol when indicating that these two lines are going to intersect to form a 90-degree angle. Remember that lines could also be notated with capital letters, so we could also have another representation such as two lines intersecting, again, forming a right angle. But if I used notation different than line M and N, and I called this line CD and line AB, and let's say that they intersect at point E, you could say that line AB is perpendicular to line CD. You could also state that line EB is perpendicular to line ED, and so on. So we're not limited to just this notation here. It's important for us to be comfortable with different types of symbols. Let's consider this diagram here. Notice we have, again, line M and line L. Remember that we can refer to an angle by a number. So here we have 4 different angles, 1, 2, 3, 4, formed from these two intersecting lines. And this little notation here, that little box, tells us that they intersect to form a right angle. So we have 6 things, main points that we'd like to conclude. The first is that angle 1 is a right angle. Also, since angle 1 and angle 3 are vertical, we know that they're congruent. We also know that angle 1 and angle 4 form a linear pair. Also, they are supplementary. And as a result, since angle 1 is a right angle, and angle 1 plus angle 4 equals 180, we can conclude that angle 4 is a right angle. And then in conclusion, we can say that since angle 1, angle 3 are vertical, angle 1 and angle 4 are supplementary and form a linear pair, that 4 is also a right angle. Angle 4 and angle 2 are vertical, therefore they are congruent. We can now state a very important observation, which leads us to our next theorem. Theorem 3.8 states that if two lines are perpendicular, then they form 4 right angles. Again, this is a good opportunity for us to review our conditionals. So since this theorem is in the if-then form, we can underline the hypothesis of this conditional, which is two lines are perpendicular, and we can underline the conclusion of our conditional 2 times. And our conclusion is that they form 4 right angles. As previously observed, angles 1, 2, 3, and 4 are all congruent, and as a result, they're all 90 degrees. So from here on, if you see that little square mark from 2 intersecting lines, you can then conclude that 1, 2, 3, and 4 are all right angles, and they're all equal to 90 degrees. Taking that into account, let's look at this next set of examples. In this figure provided, we're given that line OP is perpendicular to line MN. That's right here, guys. Since they're perpendicular, we know that that's a right angle. Also, we know that NP and QS are perpendicular. So NP right here, QS right here. Let's determine whether each of the following are true or false. Let's take a look at PRN. Angle PRN, since it's formed by these 2 intersecting lines, we know that it's actually a 90-degree angle. So this assumption here, that angle PRN is an acute angle, is false. How about this assumption? Is it true that angle 4 is congruent to angle 8? Well, at this angle of the diagram, angle 4 and angle 8 are vertical to each other. Therefore, yes, they are indeed congruent. Therefore, it's true. Observation number 3. Is it true that the measure of angle 5 plus the measure of angle 6 is 90 degrees? Again, as previously observed, we said that angle PRN is a 90-degree angle. So it's certainly true that 5 and 6 add up to 90 degrees. And finally, let's take a look at this 4th statement. Is it true that QR is perpendicular to PR? QR and PR. Well, since we know that MN is perpendicular to PO, and angle PRN is actually larger than angle PRM, which is 90 degrees, we can say that this statement is false. Let's take a look at this next set of examples. Having exposure to different diagrams and relating that to our theorems and observations will help us better approach any given problem. So let's see this. It says, let's find the measure of angle EGT and the measure of angle TGC if it's true that EG is perpendicular to CG. So if these are perpendicular to each other, it's always a good idea to mark up your diagram to indicate any given information. Also, it tells us that the measure of angle EGT is equal to 7x plus 2. I'm going to mark that in my diagram. So here I've got 7x plus 2 for this portion of angle EGT. And then this angle TGC is given by 4x. So again, we're highlighting here that this portion is equal to 7x plus 2, and also that this portion of the angle, of the 90-degree angle, is given by 4x. Let's combine these two expressions in terms of x and set it equal to 90 degrees. Again, since we know that EG is perpendicular to CG. So let's set up our equation. 7x plus 2 plus the 4x is equal to 90 degrees. Now that we've set up an equation, let's do some algebra. So, combine like terms, we know that 7x plus 4x is equal to 11x plus 2. And let's isolate our variable by subtracting 2 from both sides. And then we get that 11x is equal to 88. And dividing both sides by 11, we end up with x is equal to 8. So let's plug that information in over here and then answer our question in full. So here it says again that the measure of angle EGT is given by 7x plus 2. Let's plug our found value of 8 in for x and simplify. 7 times 8 is 56. Adding the 2, we get a result of 58. So that's the measure of angle EGT. Now let's tackle the measure of angle TGC. Again, we know that it's equal to 4x. And since we know that 8 is equal to x, we get 32. And it's also a good idea to know how to self-check. Again, these two angles should add up to 90 degrees. So when we add 58 and 32 degrees, we do in fact get 90 altogether. So we're confident that our answer is correct. All right, let's consider the critical thinking concept. How many lines can be drawn through point T? That would be an infinite amount of lines. I could have a line cutting through T this way, and this way. Now, question number 9 asks, how many lines can be drawn that are perpendicular to line M? Well, we know that we could have one line going this way to create a 90-degree angle. We could also have, in a different plane, one line cutting through, sort of like a dart, going through, perpendicular to this. So, really, number 10, how many lines in a plane can be drawn that are perpendicular to line M and go through T? And that leads us to our next theorem. Only one. So theorem 3.9 states that if a line M is in a plane and point T is a point on line M, then there exists exactly one line in that plane that is perpendicular to M at T. So again, let's consider our previous observations. Although we have an infinite amount of lines that can go through T and an infinite amount of lines that are perpendicular to T in different planes, we can specifically say that there is only one line perpendicular to T in one plane. Now it's your turn to try some examples on your own independently, and then come see us for questions.
Made with Doodlecast Pro.